Okay, we're going to go through, this is kind of a virtual lab. This is what we were going to do this Monday, but since we're keeping our social distance, we're going to do a virtual tour of the Morrisville Dairy Complex milking system. So here's that kind of schematic again. We're going to focus on out here, laser pointer, we're going to focus on the milking unit. So our milking unit, we've got our teacup down here. We've got the two chambers, the outer and the inner. We've got the liner that goes through, short milk tube here that goes into our claw. Claw's got a common drain out through the long milk tube. We've got two different pulsator lines because we alternate front. So we've got pulsator line coming down. It goes left and right in the front, and then the other pulsator line coming down, going right and left in the back. So pulsator line, short milk, I guess you call that a short pulsator line, and then the long twin one that goes all the way up to the pulsator at the top of the parlor. You got your claw here. This one is sort of designed to prevent impacts. We'll talk more about those when we get to mastitis, but an impact is if we have air, a liner slip, air getting in past the teat, it accelerates the air coming in. It moves at a high velocity. And if this side is lined up with this side, that high velocity milk can move from one side to the other and actually be forced droplets into the opposing teat. While we're milking, the teat end tends to be open. So impacts, the liner slip forcing the milk this way at a high speed, it continues with momentum into the other teat. And this is one of the reasons why in the old days we had staff cows. If they got staff in one quarter, they more or less got it in the other quarter. One quarter tended to slack off, more liner slips. It would force bacteria from one quarter into the other quarter. In the parlor, we've got your monitor there for each of the stalls. And then above that is our vacuum gauge. So digital vacuum gauge, this says whatever the one down in the pit says. We focus on that a little bit more. We're running about 13 inches of mercury in our lines. That probably means we're down 12 or 11 at the teat end when we get there. So we're not being told very aggressive on that. We have a little bit longer milking times, but they're still quite quick compared to what we used to have before you guys got here. We've been a little less aggressive about drawing the milk out quite as fast. So if we take a look at our milking unit, we've got our claw here. We're going to drain into our long milk tube. It's going to go down, around, and it's going to go into the console here. So our milk with a little bleeder valve is going to push that milk down into the parts that have to get taken care of. Open that door down below. The milk is coming in and it's coming down. We have our automatic vacuum shutoff associated with our ATOs, automatic takeoffs. So we have a pinch valve here that will close that line down, and the vacuum will cease there, and the milk machine can come off without damage to the udder or liner slips or anything like that. We go down our long milk line into our weigh jar. So every time this fills up and dumps, that records a certain weight. I think it's a quarter or 3/10 of a pound, which to the computer. So every time that happens, you add that up and you get your total weight. Also, how fast those happen can help you get your rate of milk harvest through. We leave the weigh cell, weigh jar, whatever we want to call that. We move into our AFI lab. From our AFI lab, we go down another milk tube into our pipeline down below. So leaving Affy Lab, we go to our milk line, we go down into our blow line, our milk line going through. So stainless steel, this is going to empty down into our weigh jar or our receiver jar in the pit. So everything there is sloped to make sure it moves at the right speeds.